Live.
Yeah.
Mm-hmm.
No, I already saw him shipping. I saw him shipping. Huh. Good light, so it's first like that. That should.
There we go.
The Milky Way rising. Never gets old.
Never gets old.
Yeah, it's beautiful. Love the Milky Way rising
Yeah.
shot here. That's really nice. It only gets ancient.
Yeah.
It's awesome.
So if we're made of star stuff, then I guess we're already kind of ancient, right?
Yes. We're recycled
Us
material.
being young and getting old, but we were already.
Don't remind me.
How old, Mike? Billions of years old? I mean, how old is
There you go. Yeah. Yeah. That's the way to go. We're riding on top of a billions of years time wave.
Yeah. How old is the iron in our blood? You know, calcium in our teeth. It's old.
Yeah, red.
So neat.
So.
How is everybody today?
Fantastic.
Echo.
How about you, Annie?
I'm good, but I'm echoing.
Looks like you got your video working with Tyler, so that's cool.
Yeah, Tyler helped me
Excellent.
hear myself. It's so weird.
Your audio sounds a little off there, Annie.
I don't know how to fix it.
Yeah, and I see two
Can't
Andes.
tell if that's you making your voice sound strange or if that's really an electronic problem.
It's an electronic problem. It's so drastic.
Is it?
I don't know how to fix it.
You don't know how to fix it.
Mm-mm.
It's working okay now.
No, I can hear myself still.
Maybe it's coming through your other computer that's logged in.
Yeah, I don't know why I'm in twice.
First off, you don't need to be putting it there.
So, Mike, what did you think of the Global Star Party last night?
I was only able to watch a little bit of it, but saw the beginning with David Levy and
Oh yeah,
then I had to leave just as David Eicher's talk started up.
okay.
Oh, that's a really great talk. Yeah, the Galaxy talk from David Eicher. Definitely try to watch that, Mike. It's really cool.
Okay, good. Yeah, we didn't have any bad weather here, but I noted there on the comments last night that there was a tornado warning about an hour east of where David Levy lives, down in southern Arizona, southeastern Arizona. And then shortly afterwards, there was another tornado warning about an hour north of me. And I live about an hour
In
north.
Arizona?
In Arizona, I mean,
What?
it's just crazy. We've been having
Wow.
Tornadoes out there.
and actually some tornadoes. So
Wow.
it's been crazy with climate change.
Yeah.
We're getting
Hey,
unusual.
Scott, is this better? No, you can still hear me twice.
I suspect it's because
I don't hear an echo, Annie. I don't.
You don't hear it?
No.
Yeah, you're coming out really clear.
Okay. Because I can hear myself talking.
Echo.
That's what's making your
Turn down the volume.
you mess up your voice. So
Echo.
Because it's a little bit distract.
I think you have to,
You're
because
distracted.
you're logged in twice, Annie. So you have to find that other session, and that's probably what it is.
Scott, can you kick her off?
Yeah,
You
you maybe
kick
kick
her
off
off? Yeah.
the
Wait,
the non-video one.
wait.
Yeah. Kick her off the non-video one.
Yeah, that's probably getting some audio somewhere fed back.
Kick her
20
off the
seconds.
non-video one? What do you mean?
Yeah,
She
there's
has-
two.
Oh, I see.
That
It's-
one.
I
Yeah.
did it. Did I do it? Am I
You
going?
did it. Yeah.
Okay.
No more echo, right?
Yeah, no more echo. Thank you.
All right.
That was
Cool.
messing me up big time.
Mission accomplished.
Yes, now I can give Tyler back his headphones.
Awesome.
Hello, everybody. Oh,
Whoa.
that's
Echo,
a,
echo,
I'm in like an
echo.
echo chamber. Echo.
Echo.
There, I fixed it.
Echo. Echo.
So anyhow, some of the people here in chat are remembering the coming attractions thing with the, I don't know. Do you remember that, Mike? Do you remember back in the day? You do, huh? That's right. They actually used that thing in the Brad Pitt and Leonardo DiCaprio Quentin Tarantino movie, Once Upon a Time in Hollywood. So
That's a great movie too. I mean, it goes where you don't expect it to.
yeah, it's pretty intense.
It's a pretty cool
intense.
movie.
But anyways, we're glad that you guys are all here with us today. And today, of course, we have our regulars, Cameron Gillis and Kent Marts and Annie Scarborough. But our special guest, who's been on before, is Mike Weasner. So, Kent has had an ongoing theme about protecting dark skies. It's not just a theme; it's a battle cry for him and for Mike Weasner as well. So we're going to turn this over to you guys, but it's a good story, isn't it?
This is a success story we're going to talk about. But let's get Annie. You have anything to talk about, Annie?
She's looking at us. What?
Yes.
Of course she
yes,
does.
Yes, I always love to talk. Don't you know that? Haven't you
Echo,
figured that-
echo.
Haven't you figured? I
echo.
don't have an echo anymore. I passed it on to Scott and he took care of it. I just want to remind everybody about the astrophotography contest that's going on. It's going to run through the end of October. That is solar system. So anything in the solar system, just submit those entries and we'll get them looked at and then announce. I think we only have 3 people right now, 3 or 4 people signed up.
So
Yes,
if
Kent.
I had a picture of a cat silhouetted by the moon, that's
I mean, well, it is almost Halloween. If you can catch a witch in front of a moon,
That
I'll
would be
work on
cool.
that.
That would be really cool.
Yeah.
Yeah. No, I'm just kidding.
Timely too.
Yes.
Timely too. So, so we have that going on. And then, I've had a couple people email me about Bino viewers, the pre-orders of Bino viewers. We, are hopefully, looking at those coming in the next month or so. So I just want to let everybody know that's pre-ordered. Those are members. We'll get those pulled and sent out, immediately for that, or, we'll call for payment and things like that if you haven't paid for it yet. So, so we got that going on. And, other than that, I mean, we're trucking along.
Yep.
We're really excited around here. We have trucks coming in left and right like crazy.
Yeah, I saw a bunch of 127 Appos coming in that's going through QA right now. And so, yeah, it feels like old times again. So
Yeah, so we'll be watching the
That's great to
website
hear.
because we'll update all that, and as inventory comes in, and yeah, it's hopping around here. So, but yeah, I don't think there's really much left, but yeah.
One hot item we've got in is going to be the two-room pop-up observatory tent. We sent an email yesterday and we sold quite a number of those overnight.
Yeah.
And they're a great project as well for people who are out and about and doing work away from home, or want to block out of the wind or shield a street light or something. So anyway.
Yeah, and that's one good thing about the Explore Alliance is, because we did pre-orders with those as well when we first had them. So, that's the great thing about being an Explore Alliance member is you get first dibs and discounts at that. So like when the Bino viewers comes in, our regular customers don't know about those yet. And so those people that have ordered them will already have their order placed and they're first to go.
And the Bino viewers are available only for paid members of Explore Alliance.
Yeah.
So
So-
you have to be a paid member of Explore Alliance to buy the Bino viewers.
Yeah,
So that's a different
That's-
tack of.
yeah, but how does that
object.
work? Let's say you're not, okay? Let's say you're
Okay.
not,
So
and you want those Bino viewers. What
The-
happens?
You will go to our Explore Alliance, our Explore Scientific website, go to Explore, find the Explore Alliance tab, hover over it and find the Explore Alliance membership, click on that, and it'll take you straight to the page so you can join as a paid member. If you don't want to do that and you want to call me, that's great. Call me. I will be more than happy to help you make that payment over the phone and get you joined up. So,
yeah, but
Okay.
Annie, what's the secret?
what do you mean? What's the secret?
Well, the secret, because the membership costs $100, right?
Oh yeah. So the
Yeah, there's a
membership-
little hack here. Yeah,
There
it's
is a little
Explore
hack.
Scientific hack.
Yeah, so it's $99 yearly, but we give out a $100 gift card for joining us. And that's every single time that you renew. So you get your money back to spend it on some great Explore Alliance
Right.
product.
So if you want those
Make a
Bino
dollar.
viewers, for example, they're like $200, $250, something like that. Okay. So the hack is that you call Annie, okay?
That's
You
right.
get the membership. She instantly applies the $100 on that purchase. And you got the Bino viewers and you have a platinum membership. for the
That's
same price,
right.
Hey, it
And-
worked for me. Annie helped me with an eyepiece at the beginning of the year.
Yeah.
That was awesome.
And
Yeah, it
as
worked. Go ahead.
As Cameron said, you actually make $1 on the deal.
Yeah.
Yeah. So yeah, there's that.
Well, and it's, and that's great, making $1 deal is great too, but there's also amazing benefits with Explore Alliance membership. We have that care coverage that, goes for all of your Explore Alliance products, not just for one item. We have a lot of people that have joined recently that have called me and asked me, well, how do I register my telescope now? It's like, well, the membership actually is for you. It's not, it helps with, it has that care coverage for your items, but the Explore Alliance membership is for the person. And so, you could have multiple items underneath there. And then of course the VIP access to events and stuff like that, and dibs and discounts. So there's multiple reasons to join, especially the great community we have that is continuing to grow. We just had to increase our membership database 2 days ago because we're just growing and growing and growing. And there's so many out there that have so much experience and knowledge, and it's great. It's great. So.
All right. Thanks, Annie. We appreciate that.
Yeah.
Okay. So Mike, let's do the setup. Mike Weasner, former fighter pilot, person extraordinaire, iPhone photographer.
He's not a fighter pilot anymore?
Well, when was the last time you
Once
were
a
in
fighter pilot, always fighter pilot, you know?
well, I guess that's sort of true, but
Yeah.
but iPhone.
I mean, I wouldn't tell him that in person because, you know, those guys they're
have
kind of rough
secret
and
weapons.
tough.
They have secret weapons. So anyway, does tremendous sky photography with iPhones. Just has an article in the upcoming issue of Astronomy magazine that he wrote about using a smartphone for astrophotography.
Wow.
It doesn't right in front
Trying
of
to
you.
hold it up, but it keeps disappearing here.
Yeah.
So anyway,
There we go.
I brought Mike on, and as we talked about last week, we're going to start launching into some deep dives into light pollution. And Mike was one of the first people I thought of bringing on the show because he did battle is probably a very strong term for what happened because it unfolded pretty easily. And I'm going to do the setup real quick, Mike, and then I'm going to share the before picture. So talk about you live in Oracle, Arizona, up on the east side of town near Oracle State Park, and have pretty darn dark skies, right? And then what happened?
Okay, well, let's back up a second. Back at the beginning of the program, Scott was showing a video taken from the International Space Station. And we were flying over some cities. You could see some lightning off in the distance. But when you look down at the cities, you say, oh, geez, that's pretty. But if you think about it, that's a lot of wasted light going up into the sky. Now, where's all that light coming from? Well, the bulk of it is coming from businesses and street lights. Businesses are out there lighting up their buildings. They've got lights pointed up from the ground because it's easy to put lights on the ground pointed up rather than putting them up on the top of the building and aiming them downward. So that's all that light you saw in that video. That's light coming from mostly businesses and street lighting in those large cities and small cities.
Which means wasted electricity.
Means a lot of things.
Yeah.
And in fact, before we get going into the specific story, there was a great tweet that I just saw about 30 minutes ago up on Twitter from a guy who runs a Dark Sky Alliance. His Twitter handle is Dark Sky Alliance, all one word. And he's talking about light pollution. And he notes that we were taught that light is good. And these are kind of quotes from his tweet. We were taught light is good, keeps us safe and efficient. Very little education, though, is going on about the impacts of it, using it without some sort of consideration, although that is certainly increasing. He notes, and this is probably one of the most important points I've seen up on any of these Twitter posts from anybody. We've learned over years how precious water is. We're told, turn off the taps when we're cleaning our teeth, use better shower heads, use better washing machines that are more efficient using water. We need that same education with light. And that is just so true, absolutely so true. So we've seen over the years, air pollution, water pollution, those have gotten a lot of publicity. Light pollution, we're still trying to tip that needle a little bit more on the impacts and the negative impacts of light pollution. So, as I said, businesses are the ones that are sending a lot of that light up into the sky. They're leaving their lights on all night long, even if the business is closed, because they want their business to be part of their advertising. You see their names up on the side of the building. You see the structure of their building. You might see their iconic logos and things like that. And this was a business up here on the west side of Oracle, very near where I live. I'm on the west side of Oracle, small little town. Oracle State Park is over on the east side of town. It's about 4 miles from where I live. I had noted after we moved up here to Oracle and even before how dark our sky was. So I was sitting out in my observatory one night in early 2014 saying, hey, I've got very nice dark skies. There's a state park just east of me. International Dark Sky Association has this International Dark Sky Places program. Maybe it's appropriate that we get this park designated as an International Dark Sky Park. Well, as part of that effort, you have to go out and approach businesses who have some not very well designed or installed lighting at their facilities. And here's an example. This was a Circle K. It's basically just a few blocks from where I live. I'm above them, so I did not see this light. But those lights, which are hanging down below the ceiling line over the pump area, were obviously blasting light out all across the countryside. Just blasting it up onto the hill 2 miles away. People driving on the street going past this Circle K had noted many times that whenever the streets were wet from rain, there was so much glare out onto the street in front of this location that it was actually dangerous. They could not see. There was so much glare coming off of these low-hanging globes from their lighting. So I approached the manager of this store as part of our effort to get Oracle State Park designated as an International Dark Sky Park. And he was just incredibly supportive. He said, yeah, I want to do something, but I can't. I'm the local manager of the store, but this is a franchise store. You need to talk to people up in Circle K management up in Phoenix. So I reached out to them, told them that we were pursuing the designation for Oracle State Park, and we would, the community, the park, the citizens would be thrilled if they could do something about this lighting. My initial concept was, hey, just install some sort of simple metal shielding around those light globes that are hanging down, and that would block the light from going out horizontally. And while they were not against the idea of doing shielding, they said to me, well, we're doing an LED retrofit for all of our stores in Arizona, and maybe we can divert an installation that's going in down a Tucson store, maybe we can divert that up to your Oracle store. And in fact, that's what they did. They replaced all of those bulbs and globes that were hanging down below the ceiling line with these flush mounted LEDs. Unfortunately, what they had already purchased, thanks to their consultant who recommended these, they're 5,000K, but they are now up into the ceiling. There's no light going out horizontally. And as you can see, just looking at the shrubbery behind those lights, if you flip back one time there, Ken.
I closed it. Let me see if I can open it.
Okay.
Go ahead, keep talking. I can.
Okay, yeah. So you can see how dark the surrounding area is behind those fixtures, behind the gas pumps. And if you look at the before picture, you can see the trees back there is all nicely lit up. Everything is just, so well lit up that it's ridiculous. Why are they shining these lights out? That's always the question we ask. Why are your lights going out beyond your property line? What's the point of that? Why are you spending money to do that?
So look at the difference back over here on this fence right here too.
Yeah, a neighbor's building, another business over there. They're lighting up the building over there. These are basically same exposures and from essentially the same location. So if you flip over to the after, so you can see these lights are less visible. There's less wasted light. So now the lights are going directly down where you want them. And that's exactly the right thing. So these are the types of lights that they're installing in all of their stores. During my discussion with the regional management people up in Phoenix, they said they have this long range facility lighting management plan. And one of the things they're planning on doing over time is that interior lighting is not going to be shining outside and be visible from outside the store. So again, that's another source of wasted light, wasted energy. If you have interior lighting that's lighting up outside, why are you doing that? So they have taken it on as a corporate goal to eliminate or reduce that interior lighting from being an impact outside of the stores. So that's one business, a very large business, lots of franchises all over the country, and they're doing the right thing just because we here in Oracle contacted that store. Big success story. We're very proud of that. And we're very proud of them. Circle K did a great job.
That's
So
awesome.
Does Oracle have a lighting ordinance, or is it just free form?
Oracle is an unincorporated community.
Okay,
So the lighting ordinance that applies to stores like this is the county ordinance. In 2010-ish, I was asked to review an update that they were working on for that county ordinance, and it was pretty bad. So I said, hey, county, take a look at the Pima County ordinance. Pima County is the county right to the south of us, very large county. And that's where a lot of the astronomical observatories are. Kitt Peak is out there. Mount Lemmon is out there. The county and Pima said, we have to do the right thing for protecting the nearby professional observatories. So I told the Pinal County to do the same thing. Take a look at their outdoor lighting management code. They did. And in fact, the Pinal County code is pretty much modeled after the pretty good Pima code. So the code that got released in 2011 now has a lot of very good outdoor lighting requirements. Unfortunately, as is the case in many jurisdictions, they don't have the capability of enforcing those regulations because they don't have light meters to go out and see if they're, if the lights are too bright. They don't really have a good way of detecting, other than word of mouth, if somebody is leaving more than 50% of their outdoor lighting on after 11 p.m. They don't really have a good way of measuring uplighting. The code says absolutely no uplighting. Horizontal is okay, but you can't have any of the light going upwards. When I contacted them about a business that had some uplighting, they said, geez, that looks bad, but we can't do anything about it because we don't have a way to measure uplighting. Huh? If you stand above the store and you can see the light, isn't that uplighting?
Well, wait for a foggy night.
Oh, there's absolutely all kinds of ways to see it. But from a code enforcement standpoint,
Measurement, I see.
Because they don't have any measurement. They couldn't take a protractor out there and measure.
Okay, that's like saying I can't prove it's raining, but I'm really wet.
Exactly right. Exactly.
Wait a minute, can't they use a light meter or something, like a spot?
You can use a light meter to measure the brightness. But when I contacted them once many years ago, their light meter had died, so they hadn't got a new one. The light meters that they have to use for code enforcement, they have to be calibrated. They have to be continuously calibrated, which means there's a big ongoing expense with those very expensive light meters because they become a legal issue. If you go out to a business and you want to cite them and it turns out your meter's not calibrated, that fine is going to get thrown out of court.
Okay, so
that's part of the problem.
When were these pictures? When were these pictures taken?
Where was that?
When?
These were taken in 2014 and then 2015.
Okay.
And they're still that way. They still have these good lights. One of the comments that I've made to people who write code, don't put in something that you can't measure. If you say, your lights can't have any uplighting, that's fine. Or but you can't measure that. Just say, hey, your lights can't shine beyond your property line of your business or your residence. You can see that with your eye. You don't need to go out and measure that if the lights or the bulbs are visible beyond your property line. But code people typically don't write the code that way. But anyway, this was a success story. And you get one like that, this becomes a showcase for your community, your local area. And it's something that you can go to other businesses and say, hey, look what your neighbor business did. This is really good.
So
this
you
really
touched
helped the community.
You touched a little bit on the color of the lighting. We're going to focus on in a future issue about that specific issue because LEDs, when they first hit the market, the astronomy committee was pretty excited because they were very directional and there was a lot of talk about this was going to really help light pollution. And the exact reverse has happened. LEDs have created more light pollution because of one, the color, and two, I can make a whole lot of light for less money than I could make with the old bulbs, and more light is always safer. So let's make a whole lot more light.
Yeah, there was a study done, and I think it was Great Britain, after a lot of LED conversions were done. LEDs were touted as being, inexpensive, low maintenance, you would never have to replace them for decades. But it was that cost savings that was going to be important to businesses, to residential people, from a lighting bill perspective. Well, as it turned out, as you said, Kent, people have seen that low cost for the installation, but they've added more of them. So the study over in Great Britain said that they saved 4 times what they were spending for the old lighting, but then they increased the lighting by 4. So they're now spending the same amount of money for 4 times more light.
Yeah.
Which is
So-
totally not the concept.
This goes back to budget problems. A lot of times it's a use or lose. Okay, so if you've budgeted, I don't know, $15 million for new lights, and now you're saying, well, I could save some money. I'm gonna cut $5 million out of my budget, okay, and give it back to you guys. By the way, I'm not ever going to see that 5 million again because it's use or lose, right? So it's that kind of accounting that might be driving some of those problems.
And it's also, the electric companies didn't really want to say, we're going to cut your electric bill by some amount.
Oh, no.
Because they're in the
They are-
business of
They're in the
selling
business of selling
electricity.
electricity, right? So
Yep.
But you take
Okay.
a city like Tucson, which recently pretty much has completed their LED street lighting upgrade. They use those cost savings for the original purchase and for the ongoing maintenance and using less energy from a city perspective to install things like remote access to every single one of their lights through a Wi-Fi network. And so they can now dim those lights on a schedule, on demand, whatever they need to
Nice.
do. If some security incident happens in some neighborhood and the police says we now need more lighting while we're doing an investigation, they can turn the lights back up. So they've used that extra savings to actually create a benefit.
Okay, so moving on, I'll tease this a little bit. We've, on the 2 weeks ago, I think it was, we talked about light pollution and bird migration. The University of Arkansas released a doctoral candidate's research that discovered that night pollinators for apples are more important, or at least equally important to daytime pollinators. And it's something you don't think about. All the birds migrate at night, almost exclusively. The songbirds migrate at night. And there's this massive migration people don't see because it's at night. Weather radar allowed us to see that. Well, this study the University of Arkansas did in their research orchards determined that nighttime pollinators are probably more important than daytime pollinators, but they're at night so you can't see them, so you don't even think about it. And it's a whole new field of research that is directly affected by light pollution. If you've got light traps, lights, bright lights near your orchard that attract the moths specifically, you don't get as much pollination. And, Newton's laws apply to a whole lot more than physics. For every action, there's an equal and opposite reaction. You put up a bright light to make it safe, and now your apples don't get fertilized at night. Interesting quandary. I'm trying to get somebody on the show to talk about that and how they did it and the impact they see from that and from light pollution. So that may be in a future episode. I'm working on that as well. So go ahead, Scott.
I have some comments from our chat here. Of course, we know of some of the victories that Pekka has had in Stockholm, Sweden, which is wonderful. And we wish that he has more successes in that regard. He's watching the program. We have, let's see, everybody saying hello to each other, which is cool. Let's see, I have to decide. Oh, hold on. There's some comments here about light pollution I wanted to read. Lots of comments here. Oh, Tarek in the UAE. He says, I already mentioned that there are streetlights in front of my house that are waiting to be operated. He says, and they aren't kind. I can use any kind of type of laser. Apparently, you can use any kind of laser or device to turn them off. But there's no way to reach municipal to talk about it because it's all in the streets now. Tarek, I wouldn't want to lead you down a path where you might get in trouble, but I do know of amateur astronomers that have set up lasers that are permanently pointed at lights, and they only turn them on when they're doing astronomy. Okay, which then momentarily turns off those lights. So those kinds of things can be done. But I do agree that you should seek permission before you
Nah, just
have
do
some
it.
people knock at your door for shining laser lights at. But that's the right thing to do, and I think Mike would agree with me, is to formally approach the right people. That is how Pekka did it as well. So
Yeah, and there are shields that can be installed on streetlights to block the light from shining onto an individual person's property or to a group of houses. I've seen that in quite a few installations on streetlights around the Tucson area. But you have to request it. You might even be asked to pay for that shield to be installed. It's basically a $20 or $50 piece of metal that they just go up and mount on the streetlights.
sure.
Some streetlight fixtures don't have the capability of from the manufacturer of mounting a shield, but there are some aftermarket things that can be applied if you hit the right person in the government.
Right. You just got to keep asking and keep digging. Dean Bostetter, Senior, is asking which 1.25-inch light pollution filter is best. He says neighbor lights abound, but I don't want to lose image clarity. Any comment?
Well, I'll throw out a comment. Last year, I won a 2-inch UHC filter from a company that we won't name because he's hosting this show right at the moment.
Wouldn't be an Explore Scientific UHC filter, would it?
Even here in my
Did it work? Did it work at all?
in my non-dark, in my non-light polluted area, I found it to be an excellent filter. I've used it on my 12-inch telescope, and it does an incredible job. So the optical quality is excellent. Certainly the reduction of non-wanted light frequencies is excellent. I've used it, when the moon is in the sky, and it blocks out all that excess light pollution from that big object out there hanging in our sky. So I can say, hey, check out the Explore Scientific pollution filters.
I will put out a disclaimer, though, that there are other very fine quality light pollution filters out there. I think everybody who makes a light pollution filter kind of has their own little recipe of what they're going to attenuate in the spectrum. But in general, I really haven't run into bad stuff. Usually where I see bad filters is where they're not using optically flat glass. Maybe they're not, the coatings also don't have some anti-reflection coatings, those kinds of things, so, but I would say if you're buying, from a reputable company, you're not trying to buy it on the real down low cheap, okay? Because real down low cheap will get you real down low cheap performance a lot of times. So, that would be my recommendation,
Absolutely. And for those that don't know, the optical flatness, like Scott said, that's kind of a critical thing if you want good image quality. There's a simple way to say, good and bad. This filter looks good. This filter looks really bad. When you have a filter, when you get a filter from some company, hold up your filter. And this isn't a filter because I don't have one handy, but if you look through the glass and you tilt the filter a little bit as you're looking at something through the filter. If you see distortions as you're turning it around and looking through that filter at an angle, the poor optical quality will become evident very quickly.
Yes, that's
What
right.
will it look like? Wavies,
Like
distortions?
wavy, especially when you're looking at a polished surface, you can see scratch and dig, you can see a lot of things.
And if you see the object beyond that, you're looking at, a tree or a brick wall through that filter as you twist it back and forth, it's going to get distorted. And whereas a good optically flat filter for a piece of glass, when you tilt almost all the way horizontally, it's what you're looking at through that filter is not going to be distorted at all.
That's right. Yeah, so typically, when you're finding, there are real inexpensive filters. It'd be kind of crazy though to make a light pollution filter on non-polished flat glass, where it's just float glass or something, because the coating, is expensive all by itself. A lot of these coatings on light pollution filters, narrowband filters especially, they're multi-coated again and again. This is expensive to do, so it's not so much the material cost a lot of times, but how you're doing it. And so, I have seen really bad quality color filters, where they're just not very well made. But to be very honest, I don't think I've ever seen a real bad nebula filter. I can't recall, but maybe you have, Mike. I'm not sure. So, but
All right. So let's move along. We can talk about
Yes.
light pollution forever. I know I can, but Cam's got some pictures to talk about and go through. He's got some wonderful continuing. Are we in what constellation are we in now with you, Cameron?
So we're moving from Cepheus down through Lacerta and Western Pegasus.
Okay.
Let's go. I'm gonna share my screen here. Okay, so if you recall, we ended up in our last program a couple of weeks ago. I had to take a little break last week, but we're still continuing and going strong. We were left up with NGC 40 in Cepheus. And so if I look at, now we're gonna go down through Lacerta, right over here. We're gonna come back, don't worry, we're gonna come back to Andromeda and Cassiopeia, but I'm trying to do this in an order where we're kind of following with right ascension. So as the, as we go through the seasons here, I wanna kind of comb back and forth in right ascension through the constellations so that we can all follow along in our exploration. So we're just flirting with the Milky Way. We finished the Milky Way objects, and now we're coming back down and we're moving into globular cluster, planetary nebula, and galaxies now back into, so we're going to do Western Pegasus, and then we'll end up with our last object for today will be in M15 at the far western edge of Pegasus. So let's go. Sorry, that's not the. Okay, not that one. This one. Okay, so let's go through. Okay, so just a recap where we're at. We have the database of observations, visual observations, 3,000. I was just talking in yesterday's star party that we have a big constellation of galaxies coming. Eridanus, it's a winter, kind of late fall winter constellation. That's a huge gap because at this time, before the show, I was just talking to Mike about the weather here in Seattle, in Pacific Northwest, and that it really makes it difficult for me to get some good nights in observing. So this number will probably stay at this until, like I say, the late fall, winter, when I get a chance to really go through and record all the galaxies in Eridanus. That's the kind of the biggest hole in my observation here. And so, but out of those, We have the 800 or so, what I call best and brightest. So about a little less than a third, almost a quarter, I guess you could say, of objects that that were down to 12th magnitude, 12th, 13th magnitude. And these ones I figured are good enough, bright enough, even with my Bortle 6 through Bortle 8 skies. Bortle 6 to the east, Bortle 8 to the west towards Seattle. We got a big light dome, and Tacoma to the southwest is a big one for me. So far we've explored 251 images, and those images are a composition starting off with smartphone is how I started off, and now I have an astro imaging camera. So and then many of those images are duplicates at different stages as I've improved my techniques and we've explored together 162 objects. So today we're going to cover 12 new images and 2 new objects. This is where we left off, NGC 40. So we'll just continue. And like I mentioned, it was Lacerta and Western Pegasus. I'll give a quick recap. As you all know, I've been working, I have my new Exos 2 mount with PMCA. I love it. It's awesome. But again, the weather hasn't been cooperating, so I haven't been able to put it through its paces. So I've been focusing on basically getting all the Wi-Fi, the connections, the FTDI cable that goes to my ASIR Pro, all that kind of stuff. I've been focusing on all that so that when I do get some clear skies, I can have a good workflow and good astro imaging experience. I'm realizing there's a couple of things I need to probably add to make it even better, but that's all part of the fun. I'm going to maximize what I got, and then I'll share. When I kind of shared some stuff the last time, I realized the audio quality was really bad, so I'm going to probably redo that one. You know, when I have things properly lined up and better quality. But I definitely want to give everyone an update as I get my new Exos 2 in full operations. So first object, let's go back to here. So we, like I said, we were going through, and we're going to go through Lacerta. So let me just go back an hour here just to make it easier to. So here's Pegasus, and if I go from NGC 40, I zip down, and if I zoom in, first object is a planetary nebula, IC 5217 in northern Lacerta. So take a look at that. It's about 4,000 light years away, magnitude 11.3. It's actually quite small, pretty stellar almost. It looks like a fuzzy star visually. It's bright enough to see in a smaller telescope, magnitude 11.3, and because it's small. When I take the image, if I go to my picture here, let's get rid of this out of the way. You can see that through the visual plate solve, this group of stars here, that is the planetary nebula. And as you can see, because of you know, the stars start to blow out as you start to expose. This was an earlier image. You see the big netting, and that. So it's not a high end picture, but I captured it, and it basically looks like a fuzzy star. And this is where, you know, the combination of, you know, using imaging, visual observation, everything. Use all your tools at your disposal to really enjoy different aspects. Like planetary nebula like this, very difficult to image. You know, you'd need much longer focal length and longer exposure. Maybe not so much exposure because they're usually high surface brightness, but mainly you need a much better image scale to really eke out the structure and that. But visually, you know, these blown out stars on the image are nice pinpoints through a refractor or any good optical system. And then you can easily see the fuzziness around this planetary nebula. So actually what you see here in the circle is actually what you see visually, but then all the other surrounding stars will be pinpoints. So that's basically gives you an idea. Next object, let's go to We're going down, and it's now we have an open cluster, 7243, quite bright, magnitude 6.4. I have a new set of binoculars, which I'm very happy. The Alpin binoculars from Explore Scientific, they are awesome, and I can't wait to go back and check some of these clusters visually with binoculars. You know, they're going to be pretty small. They're 7x42s, but one of the things I'm enjoying, and I just started to do when there was one clear night, where while I'm setting up my mountain doing imaging run, I just use my binocs and keep looking up and see what I can see. It's really fun to be able to kind of do both the imaging and have your binocs look up and see. You know, one of the objects that really comes out nicely are globular clusters. You know, I was looking at all the Messier globular clusters with the binocs, and they come out really nice, little fuzzy balls. And then similarly with a little more scrutiny in the future, I'll be picking out some of these clusters. So this one here should be visible in binoculars, 7243. And if you take a look at the information here. So this guy, sorry, I have some stuff in the way. Yeah, magnitude. So it's 2.5, well, 2,500, 2.6 thousand light years away. A nice, pretty open cluster, as you can see from this image here. And of course, my image not so nice, but it's still it captures, and you can see the visual structure of this. And this is a nice one because it's fairly large, but yet it's dense. It has a pretty high density of medium bright stars. So very pleasing cluster to take a look at. One of the things in my sky survey, I was pretty critical about open clusters because some of the fainter ones, they're really very difficult to really have a pleasing view. But some of these, just depending on the density and the patterns that are in the cluster, are really enjoyable to watch. And this is one of those, 7243. 7209, if I go back here. 7209 is right here. You can see there's some galaxies, but they didn't make the cut. They were just a little too faint. But they're nice. But this cluster here, 7209. I take a look at it. It's 3.8 thousand light years away. So again, most of the things that are within our local arm that we can see visually are in the thousands of light years. That gives you an idea of scale compared to last night when Hubble discovered that the Great Spiral Nebula of Andromeda was, in his initial estimation, 1 million light years away. So that you can imagine, again, coming back to that, the shock that he had. And now we're able to look at a database on a computer and say, yeah, these are in the thousands. So you kind of get a perspective on how the orientation of how close a lot of the objects are. So 7209, and visually, or sorry, on my image, you can see again a very nice, it's a little tighter group than the earlier cluster, but a really nice sprinkling of stars, and I just love it. And sometimes what's nice is usually they're about the same color. They're either a whitish blue, or sometimes a lighter blue color, but sometimes you get the occasional foreground or different star that's obviously not part of the same group, that's in a different color. That makes it nice. And this has that. I think this is a yellow star over here. Yeah, so it's really a nice cluster. Okay, let's go to now we're going to get into the galaxies. So you see we're going further away from the plane of the Milky Way. So you start to see some brighter galaxies getting through the dust lanes. And so 7265. Actually, I should probably change the. Give me a second here. Going to change. I had it. I was putting a lot of galaxies in there. I was doing some deeper studies last night. I'm going to change it to magnitude 13 threshold. Okay. So 7265. So it's a magnitude 12.2. So it's right over the edge, but it has a high surface brightness. So we look at it, it's 250 million light years. So it's pretty darn far. Actually, we were just looking at, yeah, that's a 250 million light years away. That's a far galaxy. But yet it's quite bright, so it must be massive. I mean, so you can see in the image, you know, it's, even though it shows it's larger, the core it has a high surface brightness. So surprisingly, even though it's a magnitude 12 galaxy, it comes out pretty good. And you can easily orientate it by these two stars here, and you can see it right there. It's really nice.
Right.
Yeah.
Very
And
cool.
and of course, then everyone's favorite, and if it's not, it will be one of your favorites. 7331. This is a really awesome, because it offers a lot of neat stuff. First of all, let's take a look at it. It's just on the northwestern part of Pegasus. It's the first thing that comes up. So this is kind of like an Andromeda Galaxy preview. Magnitude 9.2. Let's see how far it is. 47 million. So it's really close. And as you can see in this image, which is amazing, there's tons of other galaxies in that area, including some of these ones here. And what's neat about this is here you can see one of those galaxies in this image, right? You can see one of those close by ones. And if we pump out the, I'm going to do this again. Don't worry, I'll get to Stefan's quintet here. Give me a second. Go back. Now I was going to pump the magnitude limit. Okay, so now you can start to see. So here's that neighboring galaxy, NGC 7335, magnitude 13.4. So, you know, if you have a little bit larger instrument, let's say probably a 12 or a 14 inch, this is pretty good. I know in my 18 inch, I could see all these galaxies because they're bright enough. Well, this one here, magnitude 15.6. I don't think I could see that one, but this one here I could see. Let's see here, magnitude. Yeah, I could see this one. Anything below 15th magnitude, I was able to catch up with my 18-inch DOM. But if you're in this area, this makes it nice for all different instruments. But otherwise, if you have a smaller instrument, this is quite a bright galaxy. And because it's more dense, you can see from the image here and also from this image, it has a dust lane on one side, very similar to the Andromeda Galaxy, same orientation. It's like a baby Andromeda Galaxy, but you know, obviously further away. But very nice for any size telescope, I would say. And obviously, as you have larger instrumentation or you do imaging, you can start to go deeper with the neighboring galaxies. Moving along, if I zoom back out here, and then of course a neighbor. This is not on my best and brightest, but you can't help but include Stefan's quintet, which is actually in the same field of view, and I have an image here. This is only this is less than a degree. This is 0.8 degrees wide by about a half a degree high, just to give you an idea of the scale. So with an eyepiece, you know, in a larger telescope, what a wonderful view to be able to see 7331. You can see the dust lane, for example, it's larger. And then you have Stefan's quintet here, which is awesome. I mean, it's a nice little grouping of, like the name implies, there's 5 galaxies that are all clustered around. The brightest member, if I go here, brightest member, sorry, there's a little bit of a lag on my computer. There we go. Magnitude 12.6 is the brightest member, 7320. So, you know, it's just within a reach of my 8-inch visually, so I could actually pick it out. So it made the cut as far as the observational recording. But some of these guys here, these 12.9 galaxies, if I zoom, let me just zoom in here. These guys here, they're pretty high surface brightness. So you should be able to see them. They look like fuzzy stars. So depending on the seeing conditions, like this 13.3, really flirting with the edge, the limit of an 8-inch. This guy you can't see at magnitude 14 because he's, that's the limit of the 8-inch. But you can see with this what do you call it, with the photograph or the astrocam image, you can see all 5 members, and you can see how stellar they are. As I was mentioning in the earlier about the planetary nebula, these galaxies here they basically look like stars, and that's actually visually what you'll see. So if you have not the best seeing conditions, they're just gonna look like stars. But by comparing it to this star structure, you'll be able to identify those as actually galaxies. Very similar to a quasar, just looks like a star. Is the same thing. But if you look at the information on these guys, just to give you an idea, 47 million light years. So it's as far as 7331. Let's take a look at these guys. 7370. By the nomenclature, it should be all around the same distance. Sometimes, see, no, they're not. They're superimposed. This is what I was wondering. I remember correct. You can see also by the color, these guys are more redshifted in this image compared to the foreground galaxy. So you can see they're more in the orange. 280, so they're in the 250,000 light years. I bet you they're all the same distance. Let's take a look here, just for kicks. Yeah, 320 million light years away, so even further away. So they're not even though they're overlapping, they're not overlapping in real space. So let's take a look here. This guy, 320. Okay, so this guy's in the same group. And then here, 7319, 320. So most of them are 320, but there's one odd one, this larger one here, 7318b. Take a look at it again. That one's 280 compared to 330. So these 3 guys, smaller painter ones, are in the 300s. This guy's at 280 in the foreground, and this guy is 47, if I remember. Yeah, 47 million. So it's so neat to be able to see this, grouping, and see that you're seeing a large range in distance. Anyhow, so that's Stefan's quintet. Definitely worthy of.
Yeah, I love looking at Stefan's quintet. You need some aperture to see it visually, but you're getting this from your balcony in Seattle, right?
Yeah, exactly.
Amazing. Amazing.
Exactly.
Faint galaxies. Okay.
And I remember seeing it with my 18-inch in a darker sky before.
Sure.
And now to be able to capture it with my 8-inch, with a 30-second exposure, basically.
From the city.
Basically suburbs, to be fair. Right?
Okay, yeah, all right.
But still, city light, yeah, exactly. And it's really very gratifying. And I really like this dust lane here too in 7331. It's nice. And actually visually, this is the neat part. You train your eye when you look and you take your own images. It helps you visually. When you go back to it, it's like, you can notice that one edge is a little more higher contrast than the other edge, and so it's nice. So very pleasing. So yeah, very, very highly, very enjoyable. So make sure you check out 7331 and Stefan's quintet. Next one. Now we're going to go a little bit more benign galaxies, but they're still pretty nice. I like any galaxy is a good galaxy. This one, 7217, quite bright, magnitude 10, 54 million light years away. If we look at the picture, so you can see quite large, nice, very clearly defined. This star kind of gives it away, these two, and then you can see this very large, almost face on. Probably, and some of these, like I say, as I get better with my imaging techniques, even though they're not on the hit list of most people, I'm going to give them a little more time and, take a longer exposure and see if I can eke out some spiral arm structure out of this guy. Because I I suspect because of the orientation, it might have some neat stuff to look at with a better exposure. So stuff like that, you know, I'll be coming back, making better images, and that's all part of the fun. Okay, then
Yeah.
we have another 7332. Let me just zoom back out here. Oh, a little bit of a hiccup. I'm happy to say that I have a new computer that I've ordered, and that will eliminate a lot of these hiccups. So it's and it will help me with my imaging too. But that's probably a month away. It's in the logistics supply chain issue right now. See here, 7332. This one here, magnitude 11.1, 74 million light year waves. So another, you know, 50% further than 7331. But it has another neighboring galaxy, 7339, a little bit slightly fainter. Didn't make the cut and best and brightest, but it's still, it is, but you can visual. And I love these pairings of galaxies, and we'll see in the picture. Let me just take a look at the specs on this guy first. It's all, you see, it's right. So these guys are interacting, definitely. 70, they're in the 70 million light years. These guys are getting close, and they're going to have some fun in the future. But right now in the picture, just so nice. Two different orientations, you know. If I zoom in here, you have this guy, 7339. Yeah, 7339 and 7332 with it brighter. And it's nice because this is a good test for, you know, visually, you can see this very easily with these two stars, right? You can do a visual play solve, capture this guy. That's a nice pairing. But then you can kind of check your averted vision as you're looking at that and see if you can eke out 7339. So that's a nice grouping. Zoom back out. 7280, another galaxy. So Pegasus is a wonderful galaxy collection. It's lots of good stuff in Pegasus. It's 7280 now. Magnitude 12.2. And it's a 70, yeah, it's in the group. So we're in the 70 million light year range right now. Quite a bit smaller, but it has this triangle of stars. If I zoom in here, it has a neat, it makes kind of a kite shape structure with this triangle of stars here, which I always like that. You know, when you have some stars nearby, and then you have, you can easily see, yep, that's a galaxy, and see the orientation. So that's 7280. Moving along. 7177. Let's check him out. Magnitude 10.9, quite bright actually. At least in magnitude. 65, a little closer than the other guys. Let's take a look at the image. Yeah, so you can, you know, it's not, it has a good surface brightness. So here's one, it's in the middle of nowhere, but this one definitely visually you can capture it, probably even with a smaller telescope. I'll have to test it out again. Like I said, I'll be combing back through these constellations and all my objects when I have the smaller scopes again, and I'll kind of recheck them to see what you can see in the light blue of the skies. But for now, very pleasing. I love it. It's very distinct. You have a nice trio of stars, and then it's kind of at the end here.
Right.
There's another star nearby, so very enjoyable. Part of the fun of looking at galaxies, even though a lot of them start looking the same, as far as, you know, just like globular clusters are the same, they're not the same though. They have different brightness, different textures, different densities of their core, different orientations. Sometimes they have, you know, they're not symmetrical. The pairing they have, or their orientation with respect to the stars and the neighboring stars, is part of the fun. You know, it's kind of like scenery. It's like taking a picture of anything, right? You have a background. The background may be closer to the Milky Way, so you'll have more stars. Sometimes you have colored stars. So that's part of the fun. You're looking at these galaxies. As you know, Scott, I love galaxies.
Oh,
and
yeah.
as last night, and I just can't talk enough about it. You know, it's
Wasn't
just
that fun though? That was
yeah,
fun.
that was really fun. We're
It
going to
was
do
fun
more
to
of that.
watch Maxie have you find things up in the northern hemisphere, and you having him find stuff in the southern hemisphere.
Oh
That's,
yeah,
I mean,
we have
that's
yeah, and good tag team. It's a great tag team, and actually, Scott,
yeah,
as I get my my rig all tuned up here and clearer skies, which happens about half the time probably. We can have some really cool stuff in the after parties. We're gonna have
yes,
some. We're gonna get pretty well-oiled machine, but it's gonna take some time. But it will be. We'll get better every time, and
sure.
it's really fun to be able to share that, like you say, northern and southern hemisphere, and explore together. That's really cool. Oops, I went a little faster. Okay, last object for today. M15. Speaking of globular clusters, you can't miss this one. And by the way, I picked this one up with my binocs the other day. It's a good test for star hopping. You have the end of the leg of, actually this is the head of the Pegasus, I think, is upside down. Basically, yeah, you just take these two stars here, and you just go off about halfway or a third of the way, and bang, you got M15, and a great binocular object. And let's take a look at specs. Magnitude 6.2, quite bright, right? So easily binocular, and also, let's see, I'll view it here. 34,000. Remember, globular clusters are outside our galaxy.
Yeah.
And they are in the tens of thousands. So you could see the pattern. Galaxies, you know, millions of light years, globular clusters, tens of thousands, and hundreds of thousands is Magellanic clouds and neighboring galaxies, and then thousands is thousands of light years are deep sky objects like planetary nebula, star clusters, etc. But this guy, 34,000 light years, magnitude 6.2, quite bright. And what's interesting, to what we talked about last night, Scott, no globular cluster is the same. Absolutely not.
No,
they're totally different. They have their own personalities. Yeah, and this is one you can see it. It's
like
very,
snowflake.
it's like exactly like snowflake. This one has a very small, tight core, and then it starts to go out. So this is a unique feature of this one. And if you see this from my image, you can you see these stars here, and very pleasing because there's quite bright stars, yellow, orange stars close by, which makes it really nice to see those in addition to this beautiful ball of stars. And this is an earlier image in July, and then in August I took another image, made it a little bit more. So if you compare the two, this one here, I took a little more exposure, and you can see the tight core, and then the pixelation that you're seeing is because I did JPEG compression, but basically you see a really nice grouping of stars, ball of stars, and yeah. So, but at least now my technique is getting better. Since August, you can see a beautiful flat field. Very happy with that, and again, this is still 30-second exposure. With clusters, any open cluster, globular clusters, you don't want to go too high exposure. Actually, you want to just do a lot of stacking, and just take a lot of exposure, because you don't want to blow it out. I mean, it's very easy with a globular cluster to blow out. You can even see this one here, the central core is pretty much blown out compared to this earlier picture. I actually got a little more resolution. So you might even want to back it off, and I've been doing that to only 10-second exposures to stack that, and you'll get some pretty good good detail. So that's it for today. And yeah, and just a reminder, what I've done with all those, my setup, this is my image setup for those images, which was my alt azimuth. But I'm going to be doing, I'm getting my new rig set up with my equatorial, so I can continue to follow those as they go over zenith. A lot of the objects that we're seeing are going over zenith, and I definitely want to take advantage of the thinner atmosphere and a less light pollution directly above with my equatorial mount. So that's the big limitation of an LTAS. It's great. It's easy. It's all that wonderful stuff, but you're limited with exposure time. You know, I can get 30 seconds out of this guy with stacks, and that's what I've done so far. And you're limited pretty much to 60 degrees, I would say 60 degrees off the horizon. So that gives you a big hole over top. And the only way you're going to get around that is with an equatorial. So that's what I'm really looking forward to. So that's it for today. So the only thing I'll just say for next week, I'll just zip back out here. Okay, so I just was able to take a couple of images, not very good images, but I finished up the western or the eastern part of Aquarius. So now next week we're going to go dive into Aquarius, including the Saturn Nebula. Speaking of which, you know, Saturn and Jupiter are both in Capricornus right now. Going to finish up with M30, then a Helix Nebula or Helix Nebula going through Aquarius, and we're going to finish up this part of the southern skies, and then we'll kind of come back up through Pegasus and continue our right ascension movement from west to east. So there you go. So thanks, Scott. I'm good.
Well, great. Okay. All right.
Okay,
So
Cameron,
that's
let me throw in one little thing here. This project that you started, what, about a year or so ago, is pretty impressive. And the fact that you're still sticking with it is even more impressive.
right.
But I just want to point out that we're all kind of spoiled by what we have available to us today.
Oh, yeah. Yes.
When I started back in 1962, starting, you know, to observe the night sky through my brand new 3-inch Edmund Scientific Newtonian reflector, I used my Norton Star Atlas that was published in 1959. I used a planisphere that came with the telescope to see, you know, what part of the sky was going to be visible that night. And then I did almost exactly what you're doing. I said, what's going to be visible this night, this week, this month? And that's what I'm going to go try to see through my little dinky telescope. And
Yes.
sometimes I was successful, sometimes I was not. Of course, I wasn't imaging things with a camera of any kind for the most part, certainly none of the deep sky objects. But that's how I got started, and I'm still doing this crazy stuff still today. So you've got a great future ahead of you, sir. Thank you.
Oh, thanks, Mike. That's great to hear. And you're right. I've seen you and everything that you guys have done and what Scott has set up has really been inspirational, and I want to pass on that inspiration to more people as well, you know. And so it's great. It's very energizing, and I'm really enjoying it. Thanks, Mike.
Yeah, that's great. Wonderful. You know, there was a couple of comments here about light pollution too. Aaron Thompson was talking about that they had made a football field into an ice rink, okay, and put perimeter lights all the way around it. So when they fill that thing up with ice and then they pump it full of light, the this is like a giant reflector onto the sky. So it's
And you see that same effect, you know, in the wintertime with snow, reflecting
true.
street lights and building lights.
Very true. Right. Right.
And there was a proposal, I think it was out in Los Angeles a few months back. They were going to paint all of the streets white. Instead of having black asphalt, they were all going to be white.
Why?
Good question. Safety.
Just,
Somebody said the streets will be safer if they're bright white.
Because daytime is safe. There's no crime in the daytime.
Right.
Therefore, we need to make the night as bright as daytime, because we all know there's no crime during the day, because light is an antiseptic for crime. That's why there's no crime in the daytime. There's no robberies. There's no murders. There's none of that happens in the daytime, because light keeps it from happening. Oh, wait a minute. That's deep wrong. That's way off course. But that's what they were going to do. Because
but Kent, the key thing is, this is what Scott was saying earlier. It's all part of the budget approval process. So you by justifying it, by making an argument, right? Like you said, which is a bogus argument, they can now justify the spend, right? That's the problem.
Can you imagine how often they would have to paint the streets white? I mean, Missouri, I've seen bridges in Missouri they paint black in the fall, and by spring it's all peeled off and back because it helps absorb heat and melts the bridges. That's the only reason I can come up with that. I've never investigated it, but clearly that happens. But by spring, all that paint's gone, and it's back to what it was before.
Yeah.
Keeps the
But-
bridge painters employed.
Yeah, I think we money is the driver for all of that. So
That's
I
right.
think if we can somehow tap in, and I think Mike has the right approach there as well, is try to show, hey, this is good. You're going to be able to spend money on other things. Find it some way to make it a win-win, right?
As I pointed out in the chat last week on the show, I kind of come up with maybe a new approach here. Everybody talks about, we're spending all this money on space research, and that's wasted money. We should be doing things to help people here on the earth, the homeless, the needy, and that's all certainly important to be supporting. Well, with all this wasted energy going up into space,
Yeah,
and
just
light, that's billions and billions and billions and billions of dollars of energy, that's being wasted.
Mhm.
There are companies that say, hey, for every $1 you donate to us, we can feed 5 homeless people.
Yeah.
So you do the math, you can say, okay, that's 35 billion meals we can provide to the homeless annually in the United States alone.
Maybe feed the whole world,
Exactly.
in a year.
So yeah, a lot of money being wasted, and that obviously doesn't come into the equation when a lot of the companies are thinking about what they ought to do to be safe.
Yep. It's all about the economy.
There was a comment, Barry Allen made a comment about M15 camera, and he says, love M15, great view through my 12-inch Dob. It's also an object that I target when giving a neighborhood start party in light polluted skies. With the correct eyepiece, most newbies can see some great detail, great presentation. So, very nice.
Thanks. And you know what, just to pile on to that, I mean, if you want to impress anyone, like my own family, right, who was not really as fanatical as I am, of course, in astronomy, but they even are like, they love globular clusters. You show them a ball of stars, even with light pollution, it looks really impressive. You follow. You have even in light pollution, you can really have a nice view. So great tip. Yeah.
And let's see.
So while Scott's looking for another comment, I mentioned the Norton Star Atlas. I don't know how well this is going to come out, but there's my 1959.
Oh, yeah. Epic 1950, right?
Okay. I'm going to get something just a minute.
Yeah, actually, the Norton Star Atlas was, a standard, much like Will Tyrion's Sky Atlases are today.
Yeah, I don't know if you can see it there. Whoops. Nope, it's not going to have to turn on my well. Anyway, it does say Sky Publishing Corporation, Cambridge, Massachusetts, 1959.
Well, I think
I just wanted to show
is,
my first was Night Watch, right? Those were my Sky Atlases way back.
Yeah.
And we were just looking at Capricornus. Let's see if I can get this at the right angle here.
Orion Nebula is absorbing you and the book.
Yeah. Okay, I'm going to just give me a second. Let me turn that off. Virtual background. None. There we go.
There we go.
Okay, so if you take a look at this, let me just so you can zoom right in. Here we are, Capricornus. And what does it say? It says Jupiter 1985. There you go. So
nice.
probably so that was my first thing, and then I graduated and I got to this Sky Atlas 2000,
Mm-hmm.
and same thing. I started to do this manually, and as I got older, I mean, I love this atlas. Let's go to the same chart here. Right here. Yeah, the index. So chart number, where are we at? So that's Aquarius, Aquarius 7, chart 17. Yeah, that's okay. So chart 17. There you go. So same area, and you.
Yeah, look at this beautiful star chart.
I mean, what a work of art, you know. But what was happening is with this technology, with the tablet and that, I was realizing my eyes were getting, you know, eyes were getting harder and harder to. I was squinting with the red flashlight, and I was using pencil to write it, and that would get it would wet. So I kept it, but as soon as I got a tablet, I have to admit, I now use this kind of as an armchair view, which is really pleasing to see during the daytime, and I can really good. But instead of going outside with this on my table, I would change that. I now have a tablet, so I kind of use both. And this is the same with imaging. I mean, I love books and I love the atlas. So you want to kind of have a full experience of having both the book, so you can see that in the chair and make your planning observing. It's really nice to be able to kind of thumb through. And on the flip side, when you're actually in the field, I find that tablets and electronic star charts are really practical.
Yeah, but just to show you, nothing really has changed. I mean, this is a segment of the sky view in the Norton Star Atlas from
Oh, love it.
Yeah.
Yeah.
And if I just kind of bring it in here, let's see, there's Pegasus that you were talking about.
Yes.
So, all these star atlases kind of look the same, which is very good.
Yeah, and M15 hasn't moved.
Nope.
So it's the same, and it's so nice to see that. I mean, there is some precession and some movement. Obviously you have to get the epoch right. I think Norton. What was it? What was the survey? What was the star date on the Norton? I forgot it. I don't think it was 2000. That was Skyline.
1950.
1950s exactly. And then Norton, Tyrion updated to 2000, and now we're already in 2020, right? So there is a little bit of shifting going on.
Yeah. So this is for what they're talking about is precession.
Precession. Thank you.
This has to do with the Earth is spinning, but it's kind of like a top, a gyro where it's making a movement, and in 50 years, it's pretty easy to measure it. So. And they have to redo the star charts. Of course, with computerized star charts today, they make the precession to exactly the year, or sometimes even to the very day, of what you're viewing. So, you can check on the precession precision with the specs of your software if you're using software to do it. But there's nothing quite like holding a star map in your hand, right?
Yes. And actually, what I want to do is I want to put all of the Skyless 2000 galaxies and objects. Into Sky Safari. I think somebody's already done that, but I'm going to do it anyhow myself. And then I'm going to do a cross-reference, and basically, I want to be able to see all the things that are in Sky Atlas 2000, all the objects, and then continue my survey digitally. And I'll still be able to go back, like you say, and look at the star chart and say, so nice to, you got that instant view, a nice wide field view, very pleasing to look at.
Right. And uses no batteries.
And uses no batteries. Exactly. When there's a
And
power
works when
outage.
there's a power outage.
Exactly. That's right on, Mike. You got it.
Maybe the battery's not your
Gotta
red
have that
flag.
backup.
Okay,
Always
I'll
have
give
to
you
have backup. Yeah.
Okay.
Yep. Yep.
Very cool. Very cool.
Yeah.
Well, thanks, Mike, for coming on. Cameron, you too. Kent, thanks for coordinating this. And we will see you tomorrow. We have more programming coming up, and we have also International Observe the Moon Night moon kickoff party that's going to happen on the 9th on Saturday. So you don't want to miss that. Thanks very much for watching, and until next time, keep looking up.
Bye, everyone.
Bye-bye.
Bye-bye.
Hi friends, Vivian White here from the NASA Night Sky Network, and I just want to invite you all to join us for the Global Moon Party happening October 9th from 3 p.m. on, that's Pacific time, 6 p.m. Eastern time. We are going to have such a blast. We have great folks from the International Observe the Moon Night joining us. We have NASA friends from the Visualization Studio and moon treks and all over the place. We have Icelandic poets to talk about the moon, presenting new work that they're doing. Space agencies from around the world will join us, and we hope you will too. Please get the word out. Let everyone you know who loves the moon know that we are kicking off the International Observe the Moon Night this October 9th. See you there.
Hi everyone, this is Terry Mann, and I'm the Secretary of the Astronomical League and the co-host of Astronomical League Live. We have a special event coming up on October 15th at 7 p.m. Eastern Daylight Time. We're going to have a kind of Halloween party online. We have quite a few speakers. The first one is one of our regulars, one of our favorites, David Levy, and he will be doing celestial incantations. Next up, we'll have Mary Stewart Adams, passing between the worlds under October skies. We've also got Astro Bob, black holes where matter goes to die, and Molly Wakeling, spooky nebula of the night, and John Goss, the master of lunacy. And we do expect that name to stick. Barbara Harris, Algol, the demon star. Myself, Aurora, soul of the night. And we've got Carol Orge, the president of the Astronomical League. We're gonna put a wizard hat on him and let him work his magic. So please let me personally invite you to join us October 15th, 7 p.m. Eastern Daylight Time, right here. We hope to see you.